Okay, now we will see few problems over here. So now let us consider this problem. So the specification givens are gain of this amplifier is -5. The input impedance required should be more than 25 kilo ohms. We are expecting a current of 0.1 milliampere flowing through this drain, and the assumptions are kappa, that is Kp is equal to 200 microampere volt square, and threshold voltage is 0.4 and WL is 50. We are asked to find these biasing resistors R1, R2 and RD. So this RS is also assumed to be 100 ohm. Okay, this is one data that we are assuming. So this RS is 100 ohm. So let us solve this problem. Okay, this is, I'm just rewriting the same thing. We are asked to find R1, R2, RD. These are the values given. So since AV is expected to be -5, so we know that the expression for AV for this CS amplifier with source degeneration is AV is equal to minus GM into RD by 1 plus GM into RS. So now out of this we know these values. So I know what is AV. So I know what is I know what is this GM. Sorry, this we need to find out. So this is need to be found. This is also need to be found, and we don't know this also. So this is also don't know. We know this. So we actually don't know two parameters, only one equation, which cannot be solved now. So can we get the value of GM from the available data? So we know the expression for GM as equal to under root of 2ID Kp into W by L. So can I find the value of GM? Because I know all the values, so I can actually find out what is the value of GM. So now GM is given by, so I can just find out. It is under root of ID happens to be 0.1, so it is 2 into 0.1 exponential minus 3 into Kp is 200 micro, and WL is 50. Close the parenthesis. So it is now 1.41 millisiemens. This is the value of GM. So since I know the value of GM is also known now, so let me find out this. So this is actually -5 is equal to minus, I know the value of GM as 1.41 millisiemens. This is the only thing which need to be known. Okay, this is milli. Let me just take out the siemens. It is again 1.141 milli into RS is 100. So I need to find the value of this RD. So I can use this calc. Now it is, you can take out this -1. So this will go off. So now 5 alpha equals, open the parenthesis, 1.41 exponential minus 3 into alpha A. This is the variable now, or the unknown parameter, divided by, open the parenthesis, it is 1 plus 1.41 exponential minus 3 into 100. Close the parenthesis twice, shift calculate. So this is the value of RD. So whatever I will get is the value of RD, which is, if you can actually find out, it's actually 4.04 kilo ohm. 4.04 kilo ohm. So does this resistance keep the MOSFET in saturation or not? So let us verify that also. So unless since the value of RD is too much, so I should verify that whether this VDS is greater than VDS set or not. So this is VDS. So what should be, because VDS is how much? VDD minus of ID into RD plus RS. So that is this RD and this RS. So this happens to be, so I can actually find out it is 1.8 minus 0.1 milli multiplied by 4.04 K plus 100 ohm. So this happens to be 1.8 minus of 0.1 exponential minus 3 into 4040 plus 100. I can close it and equals, it's actually VDS is 1.386 volt. So I hope, okay, this is certainly more than VDS sat. To know what is VDS sat, how do I know what is VDS sat? VDS sat is equal to VGS minus VTH, but we don't know what is VGS is. So then how do we find the value of VGS here? But we know what is the value of ID. So ID is known. So can I use this equation of ID is equal to, for a saturation current condition, is it half Kp W by L VGS minus VTO whole square? So I can get the value of VGS from this equation. So I can substitute this. So okay, this I'm going to find out. So what is ID? Is 0.1 milli is equal to half Kp is 200 micro, WL is 50 into, this is the unknown value, minus of 0.4 whole square. Let me solve for this. So it is now 0.1 exponential minus 3 alpha equals, it is 0.5 into 200 exponential minus 6 into 50 into, open the parenthesis, alpha A minus 0.4, close the parenthesis, whole square. Shift calculate. So I'll get the value of, one of the possible value is, this is VGS is equal to 0.541 volt. This is one of the possible value. Let me find the other possible value. Let me say equals some minus 1 equals, and then shift calculate. I'll get the other value is 0.258. So out of these two values, so this cannot be electrically correct, because this VGS will be less than VTH, so it's not a proper value. So we have to consider this as my VGS. So what is this VGS now? It is 0.541. So then what is VDS sat is equal to? VDS sat is equal to 0.541 minus 0.4. Is it not 0.141? Now this is VDS sat, but actually how much is VDS you are having? You are actually having 1.386 volt, which is far more than 0.141 volt, meaning that the MOSFET is in saturation, so this circuit works. So this is an extra thing that you are trying to verify. For this value of RD, which is 4.04 kilo ohms, and this value of RS as 100 ohm, is the MOSFET is at saturation, so that it can give a gain of 5. So RD we found out as 4.04 kilo ohm. Next, okay, this is also known to us. So how much is VGS? It is 0.541. So out of these three, we actually found out what is VD, but we need to find what is R1, R2. So how do you find R1, R2 if you know VGS? To be very frank, what we have is, so we have this as a condition now. So this is now 1.8 volt. This is RD, which is 4 kilo ohm approximately, and we have this as 100 ohm, and this VGS is 0.541 volt, and this is R2, R1. This I'll say it as voltage at gate. So what is voltage at gate in terms of VDD R1, R2? Is it not equal to VDD into R2 by R1 plus R2 using that potential divider action? This is the applied voltage VDD, which is available between, okay, this is, let me say it as, sorry, this is R1, this is R2. let us name, usually we name this as R1, R2. So if this is R1, R2 and this is VDD, so this voltage is this. So but we don't know what is VG. So what is VG is equal to, it's actually the voltage between gate and the ground, which is nothing but VGS. Write a KVL for this. Is this VG is equal to VGS plus I into RS, ID into RS. So this I know as 0.541 and this I know as 0.1 milliampere multiplied by 100 ohm. So is it not now? So how much is this now? 0.541 plus of 0.1 exponential minus 3 into 100. Can you see now it is 0.551 volt. This is VG. This is VG. So now shall I now write it as 0.551 is equal to 1.8 multiplied by R2 by R1 plus R2. Correct? So now we have only one equation, but there are two unknowns. So then how do I go about solving this? So now there are two methods of finding the values of R1, R2. What is one of the condition given is R in should be greater than 25 kilo ohms. So what is this R in and R1, R2 relation? From this circuit we know that the input impedance is given by R1 parallel R2. So what is R1 parallel R2? Is it not because input has to be more than 25 kilo ohm. So is it not R1 R2 by R1 plus R2 is equal to R in? This is the expression, and this has to be greater than 25 kilo ohm. And we also know that this is 1.8 volt. The voltage that is required is 0.551 volt. So is this value of VG lesser than half of VDD? Because 0.551 is less than 0.9 volt. In such case, because this is a potential divider, does the value of R2 will be less than R1? Because you are supposed to get a voltage here half of this, so naturally R2 should be lesser than R1. So in a parallel combination of R1 parallel R2, if this has to be more than 25 kilo ohm, the lesser resistance should be minimum twice the minimum required input impedance. Meaning, if R2 is equal to twice the R in minimum, that is 2 into 25 kilo ohm. So if this is equal to 50 kilo ohm, suppose if R2 is equal to 50 kilo ohm, we know that R1 has to be more than 50 kilo ohm. When you have two resistors whose minimum resistance is 50 kilo ohm, then its parallel combination is certainly more than 25 kilo ohm. So we will be getting that requirement of R in greater than 25 kilo ohm if the lower resistance is equal to twice the minimum required resistance. So what I'll choose is, I'll use this equation, choose the value of R2 as 50 kilo ohm. This is now 50 kilo ohm, and now I will find the value of R1. So now what is the equation? It is 0.551 is equal to 1.8 into how much? 50k divided by R1 plus 50k. So this will give me, upon solving this, I can find the value of R1 as, so how do you do it? 0.551 alpha equals, this will certainly give some value of R1, then R in will be certainly greater than 25k. We'll actually find out how much is that. So what I'm trying to do is 0.551 alpha equals, open the parenthesis, 1.8 into 50 exponential 3 divided by alpha A plus 50 exponential 3, close the parenthesis, and do one more, shift calculate, shift calculate. Oh, because I think I have two parentheses closed. Okay, let me just delete one of them. Shift cal, shift cal. What is the problem? Let me just redo it again. 0.551 alpha equals, open the parenthesis, 1.8 into 50 divided by, open the parenthesis, alpha a plus 50, close the parenthesis, close again, shift calculate, shift calculate. Are you now getting it as 100 and I didn't put 50k, so now whatever this resistance you're getting is 113k. So now 113.3 kilo ohm. So this is the resistance of R1. Now if you want to find what is actual R in with R1 as 113k and R2 as 50k, so let me take R1 as, now let us approximate it to 100 and, okay, let me just go for 100. Even if you take it as 113k, is it not 113k into 50k by 113k plus 50k? So let us find out how much is that. Is it not 113 into 50 divided by 113 plus 50? Are you not getting a resistance of 34 kilo ohm? So R in is 34.6 kilo ohm, which is certainly more than 25k. So this is one way of finding the input impedance, where because we know the voltage that is required is less than half of VDD, so then R2 should be less than R1. Since R2 is the lesser resistance, assume that to be more than twice the input impedance. So with that assumption, we actually found out R1. Then let us find, is there any other possible way of doing this? Suppose if you find this difficult, so what is the other possible way? So this is, we know this is the again condition. So we know that 0.551 is equal to 1.8 R2 by R1 plus R2. So what is the condition required? R in is equal to R1 R2 by R1 plus R2. Shall I make this, because Rn has to be more than 25 kilo ohm, let me just assume this as maybe 30 kilo ohm, because 30 kilo ohm is certainly more than 25 kilo ohm. So let us assume it as, because if you assume more as input impedance, it is advantageous for the circuit. If it is so, shall I write what is R1 R2 now? R1 plus R2, is it not equal to, so suppose if you use this equation, shall I write R1 plus R2 as 30 kilo ohm by R1 R2? I can write it this way. So now what is this now? So now I will use this relation. Over here and then try to solve for. So is it not 0.551 is equal to 1.8 R2 divided by, what is this? Shall I now write it as R1 R2 as 30k divided by, okay, now what is, how can you do is, this is one possibility. Let us find out. So is this now R1 R2? Because this is how you're getting. So this is no. So this is actually what is, sorry. So is this R1 R2 is R1 R2 by 30k. So this is R1 R2 by 30k. So now does this R2 go with this R2? So can I find now 0.551 is equal to 1.8 into 30k by R1. So can I find R1 now? Oh, this is a small mistake. So how much is this? 0.551 alpha equals 1.8 into 30 divided by alpha A, close the parenthesis, shift cal. Now it is coming out to be 98 kilo ohm. This is R1. How much is R2 now? R2 is what? It is, what is R2 now? So we have this equation where R1 plus R2 was equal to, okay, was it actually, what is R1 plus R2 is equal to, was it 30k divided by, I know this R1 is, now this is 30k is R1 parallel R2, is it not equal to R1 R2 by R1 plus R2? In this R1 is equal to 98k. Can I find R2 now? I can find R2 using this equation. Is it not 30 exponential 3, or simply make it as simply 30 alpha equals, so what is R1? R1 is 98 into alpha A divided by 98 plus alpha A, shift cal. Now you will get the value of R2 as 43.23 kilo ohm. So now you have R1 as 98k, R2 as 43.23k. So the parallel combination of this is 30k, and this resistors will yield me a voltage of this. So now you can see how much is VGs. Is it not 1.8 into, how much is this R2? 43 point, this is just a confirmation. Is it not 98 plus 43.23? Let me just do that. So this should be giving 0.551. 1.8 into 43.23 divided by 98 plus 43.23. Are you not getting 0.5509? Is it not 0.5509, which is equal to 0.551? So this way we can find the value of R1, R2 in two different ways. You can assume, okay, both the solutions are perfect. Here you assume the value of R2 to be twice of R minimum, and you found the value of R1. Here it is slightly different way, but both approaches are perfectly fine. So what is the design now? So you have RD is coming out to be 4.04k, R1 in this case it is 113k, R2 is 50k. So this will give me all the specification of AV is equal to AV is equal to 5 and an input impedance of minimum 25. So let us verify this in LTspice. Let us substitute these values and then check out. See now, what I actually did is, we have the value of R1 as 113.3, this is 50k, this is 4.0k, so and so. I am applying a sine wave of 10 millivolt, so it should have a gain of 5. So let me run this. Okay, these are all the specifications you have. You can see the current is almost okay, now this is the current, which is almost 1 milliampere, sorry, 0.1 milliampere. So let me find the gain of that. To find the gain, let me do transient analysis. So let me just give it up to 1 millisecond and let it be 0 here. Let this be 0 and give it as 1 micro. This is done. Now let me run this. If I run, you can see this is my okay, let me again run it. See, this is input and let me see what the output is. So let me see the output here. If you actually measure the peak to peak of input, the peak to peak of, okay, let me just find the okay, fine. How much is W-bell? W-bell is 50, fine. So I'm looking for a gain of, okay, if you see this peak to peak, I'm expecting gain of 5. This is, you can see it is out of phase. If you double click on this, I'll get peak to peak of input. Why the peak to peak of input? Okay, let me just check out. Let me see what is. Okay, let me just take out this F5. I will take out this and I'll take this here. This is my input. I'll measure one at the peak, one at this point. Can you see the input voltage is 20 millivolt? That is, peak to peak is 20 millivolt because the peak is 10 millivolt. This is input. What is the output? Output is almost 100 millivolt. So I have, what I have now is V in peak to peak is 20 millivolt. V naught peak to peak is 100 millivolt. So what is AV is equal to V naught peak to peak by V in peak to peak, that is 100 milli by 20 milli. So this is equal to 5. So gain is 5. How about negative sign? So negative sign can be verified by the out of phase. Can you see the input is actually going down, output is increasing. This is the output. If you want to know whether it is output or not, what you can do is you can just have a label, say it as output, and I will just put it here. This is the output. I will wire it also. Let me wire it. Fine. Now you run it. Can you see now? This is output. I will put it here. Can you see this is my output? I will take out this. This is my output. So is it happening? Fine. So I will measure. Just zoom it. Keep one at this peak and other one is at the minimum. Is actually almost 100. The input is 20. The input is 20. You can see it's almost 20. And how do you measure the input impedance? So for measuring the input impedance, you can put a small resistor here, start varying it from 0 to higher value. When this resistance, okay, I have a circuit for that, you can just have a look at it. So let me have this. Okay, let me just modify here itself. I will have a resistor. I'll have a resistor, put it in series with this. I will make it as a variable one. This is R, VAR. I'll make it as a variable. Let me vary this resistance from dot step PARAM param and then we are starting from maybe because my input impedance now is 36 kilo ohm. Let me just vary from 0.001 ohm to, let us go up to 100, maybe 100k in steps of maybe let us make it as how much is 34.6 by 2. 34.6 divided by 2 is 17.3 kilo ohms. So let me just vary with a 7.3 kilo ohm. Sorry. Okay. ಇಲ್ಲ ಏನು ಆಫ್ ಆಗಿಲ್ಲ. It's fine. ಅಲ್ಲಲ್ಲ ಅದೇನು ತೊಂದರೆ ಇಲ್ಲ. ನೆಟ್ ಏನು ಬೇಕಿಲ್ಲ. ಬೇಕಿಲ್ಲ. Okay, I'm varying the resistance from almost 0 with an increment of 17.3 kilo ohms, and it will go up to 100k. So what actually happens here is, so I'm making this resistance 0 first, and then I'll make it 17.3, then it will become 34.k. Suppose now the concept here is, so you can just see what happens here. Just have a look at actually what we are trying to do it here. We have an amplifier. This amplifier has got an input impedance of 34.6 kilo ohm. That's what we found out. We are having a resistor here. This resistor value is starting with 0.001 ohm, and it will be 17.3 kilo ohm. Then it will be 34.6 kilo ohm, and of course we are measuring the output here. So when the resistance is almost 0, excuse me, when the resistance is almost 0, whatever input voltage you are applying, that will be completely reaching here. So this is my V signal, this is my V in. So does the entire V signal reach here, because there is no drop happening here? So you will get a output voltage, some output voltage, which is nothing but V in times AV. So which is nothing but whatever V in is there into 5 times I'll get it. So assume that now it is 20 millivolt peak to peak. So you will get it as 100 millivolt when the R is equal to, when the R, let me say it as R signal. So some Rx, when Rx is equal to 0.001. Suppose if Rx is equal to 17.3 kilo ohm, so you will have some input voltage, the output voltage will also be less. So when this resistance is equal to this resistance, so out of this voltage V signal, half of that will reach, so that I'll get the output voltage half of this 50 millivolt, out of half of this 100 millivolt, that will be 50 millivolt. So if the input impedance of the network is 34.4 kilo ohm, if I make this resistance also equal to 34.6 kilo ohm, then I will get the output voltage at Rx is equal to Rin. I'll get V0 will be equal to half of V0 max. What is this V0 max? V0 max is with Rx equal to almost 0. So what was this? This was actually 100 millivolt. So when Rx is equal to Rin, that is 34.6 kilo ohm, I will get the output voltage as 50 millivolt. So let me see the same thing here. See, exactly, I am changing the value of this R3 from almost 0 to 100 kilo ohm with an increment of 17.3. Why exactly 17.3 is because I know that the input impedance of this is 34.6 kilo ohm. I'm just making, I want to reach this resistance as 34.6 kilo ohm, maybe the third resistance. First it is 0.001, then it is 17.3, then it is 34.6. So for the third reading of this R3, my output voltage will be half of the maximum. So let me run this now. You can see now you have different values, so you can just stop it. Need not be up to 100 kilo ohm. Let me just make it up to 50 kilo ohm, so just to make it much more clear. I will run it now. Now let us see what's happening. So let me just take out this input also. Let me take out this input. Let me take out this pin also. Now what you have now is, this is output voltage. Can you see the output voltages keep having different amplitude? So let me just take both the cursors. So this is the peak, this is the minimum. Can you see this is almost 100 millivolt? Okay, forget about that negative sign. So is this 100 millivolt? Is it not corresponding to this resistance of 0 ohm? When it is almost 0, 0.001 ohm is almost 0 ohm. So you are getting V0 max, which is 100 millivolt. Now when I increase the resistance to 17.3, I can just actually move this cursor, use this arrow key. Can you see it came down? I'll just click here. I'll use this arrow key. Can you see these two are actually measuring this color? Can you see the output voltage has reduced from 100 to 66? Now you have some value of, okay, this is now 17.3 kilo ohm. Can you see the output voltage is not the 100 millivolt nor the 550 millivolt? It is neither the half nor the maximum voltage. That means that this resistance is not equal to the input impedance. So when this resistance is equal to the input impedance, I'll get the output voltage as half of the maximum. So if you actually see the third one, so what I'll do is I'll click on this, go to the third. Can you see I just went to that pink colored one? I'll just click this also. Can you see now, is it almost half of that 100? Is it not 50 millivolt? Now what does this? No, this is actually for that R3 of 0 ohm. This is for that R3 of 17.3 kilo ohm. This is for R3 of 34.6. Now if you just come back to this, as I'm just keep increasing from 0 to almost 17.3, then it is 34.6. For the third resistance value, which is 34.6 kilo ohm, has the output voltage became half of the maximum. Why it has become half of maximum is because the input that is available is half of the previous one. Why the input has become half is because this is equal to the input impedance of this, because now we know that this is 34.6, that's why we kept it at 34.6. In typical case, we will not be knowing this resistance, then we're going to sweep it. So for what value of resistance this output voltage becomes half of the maximum is the input impedance. Now for, okay, suppose what is 34.6 plus 17.3, so another resistance, it is 34.6 plus 17.3, so now it is 51.9. so 51.9 is not the available resistance. Now this is for 50k, because maximum you have is 50k. Now let me click on this. So this is for 50k, it is some value which is 40 millivolt. Now which is your input impedance output voltage? When the input voltage, when this resistance, is equal to this input impedance, I'll get the output voltage half of the maximum. So what is maximum voltage here? This is 100 millivolt peak to peak. So which is that half of that? So this is actually pink colored one. So we got that pink colored output for a resistance of R3 in this particular case of 34.6 kilo ohm. So that's why the input impedance is 34.6 kilo ohm. So that's how we can able to find the input impedance. Now we actually verifying that input impedance as 34.6 kilo ohm. Okay, hope you got this one. So maybe you may have to do one or two iterations to get this conceptually pakka. Thank you. So let me close this.